Hello. When you ask to differentiate such a function, we have x plus 1 as the numerator and x squared minus x plus 1 as the denominator. What you're going to apply is known as the quotient rule, which states that the derivative of u of v with respect to dx is the same as v du over dx minus u dv over dx all over v squared, whereby your u is actually your numerator, and in this case will be x plus 1, and your v is the denominator, which is x squared minus x plus 1 in this case. So this is all that we're going to do. So we've already said u to be x plus 1. Therefore, if u is equals to x plus 1, du with respect to dx, we're just going to differentiate the whole of this with respect to dx. And since there's a plus sign, we can separate the derivative on this term and on that term, so that we can have dx over dx plus d of 1 with respect to dx. This one will just go off to 1. And the derivative of a constant is always 0. So the derivative of du over dx will just be 1. From there, now let's get the derivative of v with respect to dx. And we had said that it's equal to x squared minus x plus 1 from this part. Excuse me. Which is the same as the derivative of the first term. Since wherever we have a plus sign or a minus sign, we can separate the derivative, and that's what I'm doing just now. Okay, now when you reach to this point, what you're going to apply is known as the power rule, and it states that the derivative of u raised to, let's say, z with respect to dx is the same as dropping z first, then u z minus 1, the derivative of u with respect to dx. So let's apply this power rule to the derivative of x squared with respect to dx. So our z, which in this case is 2, is going to drop. Then x 2 minus 1, the derivative of this u, x. This is 1, so it will be 2 x raised to 1, which is just x. So the derivative of x with respect to dx is 2x. And which other term did we have to get the derivative of? This, the derivative is 1, dx over dx is 1, and this one, the derivative is 0. Therefore, dv over dx is the same as 2x minus 1. And what else did we have? Just a reminder, u, which was x plus 1, v was x squared minus x plus 1, and d over dx is just 1. From there, we're just going to apply everything to our quotient rule, and let me just write it again. So the derivative of u with respect to v with respect to, the derivative of u over v with respect to dx is the same as v du over dx minus u dv over dx all over v squared. Our v was x squared minus x plus 1. Yes. Our d over dx was just 1 minus our u was x plus 1, and dv over dx was 2x minus 1, and our v was x squared minus x plus 1, all that squared. Okay, then from this point, all we're just going to do is just going to open the brackets and just simplify. But simply, this is the derivative of the question that we had been asked earlier. So from this point, when we multiply 1 through the whole of this other part, it will just remain the same. And on this other point, let's just expand it. So the first part was like that, it doesn't change. Then minus x into 2x minus 1 plus 1 into 2x minus 1 all over x squared minus x plus 1, all that squared. Sorry, you didn't see that. So just that, I just expanded this part such that to get x squared minus x plus 1 minus To expand this, it will be 2x squared minus x plus 2x minus 1 all over x squared minus x plus 1 squared. Okay, so expanding the numerator by multiplying the negative sign all through this, we get x squared minus x plus 1 minus 2x squared plus x minus 2x plus 1 all over x squared minus x plus 1, all that squared. Putting the like terms together, we get negative x squared minus x plus x minus 2x minus 2x plus 1 plus 2 all over x squared minus x plus 1, all that squared. And this is actually the derivative of y with respect to dx, whereby our y was equal to x plus 1 all over x squared minus x plus 1. So that's how you do the derivative for such functions. Thank you.